Hello, I'm Carlos Conde from Amazon Web Services, and welcome back to the DevOps webinar series where we explore how to enable business agility by adopting DevOps practices. So in the previous episode, Ian showed how to automate deployments and explain various concepts, including some ideas around how by automating the deployment, we make easier some tasks of creating complete environments. And he showed, for example, this tool created by SmugMug, where they demonstrated a complete automated deployment where you could just push a button to deploy a new version of their artifacts into an environment. Then we talked about the different services and the different tools that were available on AWS to allow you to achieve this goal, ranging from your own scripts running on EC2 instances through a platform as a service like AWS Elastic Beanstalk, where you could easily drop new artifacts and let the environment deploy them for yourself, let the Elastic Beanstalk service deploy them. And between them, those two services, AWS CloudFormation and OpsWorks, that we're going to talk again today, that allow you to have more flexibility and adapt to more use cases and more situations. At the end, we concluded the previous session with some best practices and some comments. And today we are going to build upon those best practices to continue to explore how we could leverage those tools that we created in the previous episodes to now start creating test environments and really deploy the artifacts that we created on an automated way. Now, what we saw in the two previous episodes are very important concepts, especially when you combine them. Episode 2, we used a CloudFormation script to create a complete architecture from scratch, right? And episode 3, we showed how you can use, for example, OpsWorks, and how you could use the artifacts provided by your continuous integration platform to deploy the code directly in the environment or an architecture that you have. If you combine those two, creating an architecture from scratch on AWS, and the second one, deploying and updating software on this architecture, you have a on-demand test environment. So you can create a complete environment from scratch, from nothing, and then deploy software and push your changes in this environment whenever you want and whenever you need. And this is interesting because if you look at one of the fundamental books that promoted the DevOps practices and DevOps movement, which is the Lean Startup book from Eric Rias, one of the key ideas of the book is, of course, being able to do quick iterations. And if you're able to create an environment from scratch and you can deploy software quickly on it, obviously it helps you to do those iterations and to do more tests. But one of the other key ideas of the book is to also be able to do those tests in a real condition, in a real environment, with also the real users. And actually, I have many customers that are using AWS, for example, to create complete integration environments that they give to the end user, to the end customer. For example, in some consulting companies or in some system integrators, they build the current environment of the project every Friday. So the end user knows that every Friday they can log into the current environment, so they can see the progress of the IT team, they can give feedback, and they have this one day to be able to play with the new environment and to give directions to the IT team. So the IT team is producing this nice feedback loop where they do a complete run. So if you're using for example Sprint as a development methodology, you're also familiar with this concept. You do a run during a week, and at the end of the week, your users are going to be able to log into the environment that you're going to create temporarily for them. Because remember, on AWS, you only pay for what you consume. So you're only going to pay for this environment during one day or even one afternoon. And then you are going to have this feedback that you are going to feed in for your next sprint on the next Monday. And if you look at it, what we did in the episode 2 is we used the CloudFormation templates to bootstrap the continuous integration platform. But actually, you could use the CloudFormation template to create any kind of architecture, right? And this is actually a very good practice to use CloudFormation templates to create your architecture, to create your system, because it follows the logic of having an architecture that is documented and treated as code, right? Because as we explained in the episode 2, now if you have a CloudFormation template, which is a text file that you are using to bootstrap your architecture of your final production environment, you can version also this CloudFormation template, which will allow you to go back to the previous versions of your architecture if you are, for example, chasing a recession bug. So one of the interesting characteristics of CloudFormation is that it gives you the ability to also have parameters. And those parameters are interesting because if you're going to create a test environment from the CloudFormation template, perhaps you don't want to have exactly the same characteristics as the production environment. For example, your production environment may have 10 web application servers or 10 web servers in the front end. For the test environment, perhaps you don't want to consume that many resources, and you could have a parameter that tells you how many machines, how many instances you put in the front end. Here I'm showing you an example of a CloudFormation template that is also used to initialize a database. So here you will be able to pass as parameters of the template the login of the administrator of the database and so on. So this is how the code looks like. So very straightforward. You just describe what is the parameter, what are the allowed values, and so on. And also that's another nice feature of the CloudFormation console. When you submit your template to be deployed and you run through the parameters, at the end, just before launching and executing your template, you have the ability here to estimate the cost. So this is always interesting because when you're doing your tests, you still want to control the cost of your test environment. So here you have, when you click the cost button, it redirects you to the simple monthly calculator with all the different components of your CloudFormation template that are added here in the cost to give you an estimation. Now, something that isn't new, but it's obviously way easier to do on Amazon Web Services is load testing. So load testing an application requires that you have this application ready in an environment, and well, with AWS it's easy to have it created with a CloudFormation script. And basically, once you initialize the environment or the fraction of the environment you want to test, well, what you can do is then create a bunch of EC2 instances that are going to generate load that will go to the application endpoint. So those instances can be EC2 spot instances. So those instances will have a way more lower price, especially if you want to do a load test during only a couple of minutes or a couple of hours. And you can use classic tools like Apache Bench to do HTTP load tests. But here the point is that CloudFormation and OpsWorks, as we just saw, will allow you to automatically create the environment that you are going to test. So you could even script the fact that at the end of each week or during the night, you can do a load test. And this is something important because we have a customer called Activision. Before they released their game Call of Duty, they absolutely needed to test the endpoints of the application, right? So if you think about it, when you are developing the backend system for a massively multiplayer game like Call of Duty, you really have to make sure that your architecture can sustain a large number of players. And here they've been using Amazon EC2 to simulate more than 2 million players on the backend system. And the idea is, especially if you're a developer, you really need those load tests to make sure that your application is behaving correctly. Because when you're a developer and you are building this kind of systems, generally you have a constraint that, for example, your code should answer to a request in less than, let's say, 100 milliseconds. Now you're writing the code for this application. How do you know that the change you introduced doesn't make your code run faster or slower, right? So perhaps you introduced a change that is going to have consequences in other parts of the application. Perhaps the change in the architecture also have consequences in the execution of the code. So the only way for you to make sure that you are going to respect the constraint of operating under 100 milliseconds is to really test your application under load conditions. And well, if you go to the AWS marketplace and if you search for load testing, you will see many of our partners and providers that are giving you tools to do load testing. And now what I wanted to show you is how to use CloudWatch to get also metrics from the instances that you are going to have under load. So I'm here with the console, and I'm going to the EC2. So here you will see that I just have one running instances that I created for this test. Okay, so it's an M3 medium instance running Linux, not doing much. Now I go to CloudWatch. So CloudWatch contains many metrics on the different instances and resources that I have running on my AWS environment. So you see I have 52 metrics available here, and if I choose EC2, I'm going to take the CPU utilization metric. I have just one instance, so it's pretty straightforward, and here are the data points. So I'm going to reduce the scale because I created this instance recently, so it doesn't have much data. I'm just going to take 1 hour ago with a sampling of 1 minute. Okay, so you see there's those 3 last spikes that don't are good behavior for this application. So I will create an alarm to receive a notification when I'm over let's say 80%, right? So the name of the alarm, CPU load, I'm gonna add a quick description. So the alarm is triggered, let's say when I'm going above 80% of CPU load for 80. Okay, so for let's say 3 minutes. And you see here, so I have the conditions. So whenever CPU utilization is greater or equals an 84, and I will put 3 consecutive periods. You see here the size of a period, which is 1 minute. So then I'm just going to send a simple email. I have a list called operational alerts that is sending an email to me. And you see here the limit, so that's it, the alarm is created. So the reason why you want to set these kind of alarms, especially when you're doing load testing, is to understand the limits of the different components of your architecture. Here, for this demo, I took an M3 instance, but you're going to be able to take other instance sizes and use the load test also to give you insights on what are the best instance sizes for your architecture, depending on the components you have and the workload they have to run, and also understand what are the limits of the system, right? Because you can generate virtually as much load as you want, but you want to understand at which point, for example, your database is going to start exhibiting degraded behavior, at which point you are going to have longer responses on your web server. Is this when you have 1,000 concurrent requests or 10,000 concurrent requests? So you absolutely need to do those load tests for you as a system operator to understand the limits of your system. So when you receive those alerts, you know when you are in the, let's say, danger zone, and when your architecture needs to be built around those bottlenecks that you detected during the load test. Okay, so back to the dashboard. This is what you see when an alarm is triggered. You see here the description of the alarm. So obviously you have the metrics here, but what's important for you on your tests is to have the timestamp of when the alarm has been triggered, because you will know during your load test at which point you reach the limit of the instance. Okay, so with everything we learned now, I wanted to talk about a last concept, which is the idea of game days. So I wanted to go beyond classic tests, classic functional tests or unit tests and load testing, and really talk about this somehow novel idea that helps you have better architectures and test your systems in a very different ways. So game days are all about simulations, right? And simulations is not something new. Here we see these two guys. They look really happy, but in fact they just crashed the airplane, right? But they did that in a simulated environment. They are just here playing with a simulator that puts them in some stress conditions and see how they can behave to try to circumvent the conditions created by the simulator. So it's all about training the teams in a very difficult conditions, because as the saying goes, good weather doesn't make good sailors, and if something doesn't kill you, it makes you stronger, right? So that's the idea of doing those tests in a simulated environment, because if you do that in a simulated environment compared to doing that in production, well, nothing important will happen or nothing disastrous will happen, but you will learn something from it. So the point is to prepare your team for extreme simulations, doing regular exercises. And this is something that in IT has been adopted already by some security teams, right? So at Amazon, security teams often do game days and even blind game days. They don't know when the game day is happening. And the idea is to inject false attacks or false errors in the logs and see how fast the teams pick them up, right? So again, it's a test for crisis situations, and try to simulate behaviors of when your architecture on where your system will not work correctly. So keep in mind that whatever the system you are building, whatever the architecture you are building, you have to consider by default that it's not reliable until you tested it, and until you tested it properly in stress situations. So we saw earlier in this session how to do stress tests, but in fact here you want to not only test the system, but also test the team that operates the system. So when you do a game days, you have a team of supervisors and the team of players. And the idea here is you are going to make a plan that is decide what is the scope of the application that you are going to test. Perhaps you want to test your whole system, or perhaps you want to test only some parts of your solar architecture, some components. And you're going to define a role play. That is, what are you going to test? Perhaps you want to test a failure scenario of read replica dying, right? And suddenly all the traffic will go to the master, and perhaps your application is at risk, right? So you want to test how the team is going to be able to circumvent this failure and to correct this failure. So first we create the simulation environment. Now, I mean, for you, it's something that you know how to do it. You can use a CloudFormation script. This is something that we discussed in the previous episode and in this one as well. So this is not a problem. You use the CloudFormation template and you rebuild a complete environment for your game. Then you also want to activate CloudTrail, right? Because CloudTrail will record all the actions that are done by the players in the AWS environment. So this is very helpful for when you're going to do the debrief and for auditing all the actions of the players. So we have many partners, like for example Logly, who are providing interesting tools on top of the logs, the raw logs that are provided by CloudTrail. So you can see on the timeline, for example, the different actions, and you can drill down in the logs to see which player, which user, because obviously each player will have a different IAM user account. So you will be able to see what are the actions that have been taken by each user. And then you need to simulate an activity, right? Because obviously you want this game day to look like a real environment as much as possible. Keep in mind the analogy of the airplane simulator, right? So the airplane simulator simulates an airplane that is flying, not an airplane that is still. So for your environment, it's exactly the same. Once you create it, once you bootstrapped your environment with CloudFormation, you need to simulate some activity. So there's different ways to do it, right? So obviously you can do it, as I explained earlier, doing some load test. But the problem of load test is that it doesn't look like a real activity, right? Load tests, you will have a bunch of instances hammering a specific endpoint, but it's not like classic traffic that you're going to see on the website. What I recommend for the game days, and even for load tests, if you want to do it that way, is to replay pre-recorded network activity. So if you're using Linux and for network administrators, you already have in mind a tool called TCP dump. And TCP dump, as the name implies, takes everything flowing through the network interface and dumping that into a file. Then obviously you're going to end up with a huge file, but storing huge files is not a problem on AWS. And then you are going to be able to replay this file with TCP replay. And even TCP dump will allow you to do fancy tricks, like for example, only capture a certain type of packets, that then with TCP replay, you can replay those actions multiple times. So you have all the tools that you need to record activity and then replay it. And what is nice is that you can replay different situations. Exactly like when I'm on an airplane simulator, I'm going to simulate, for example, an engine that is on fire. I'm going to simulate, for example, the fact that one wing is not operating correctly, and so on. I'm going to simulate multiple failures. Here, you are going to be able to replay also different incoming patterns. You are going to, for example, to replay perhaps an outsider attack. You are going to replay traffic of an old application, and so on. And once you are replaying the traffic, and when your team is operating the environment, this is when you are going to simulate the failures, right? So simulating the failures, as I just mentioned, is like in the airplane simulator. You want to test your team. They should know the procedures of recovery. They should know the system well enough to be able to fix the system, and you want to time how quickly they do this. So there's a wide variety of ways you can simulate failures on AWS. I mean, you can do it very simple. You just log into the console yourself and you just kill a bunch of instances of EBS volumes, or you change the configuration and you just sit and watch and look what happens, right? So terminating resources is obviously a straightforward way to introduce failures. If you don't want to be that harsh, you can, for example, just change the configuration of the security groups. So by removing all the incoming rules or outbound rules on a security group, you're basically blocking all the instances in the security group to access the network. So that's also pretty efficient if you want to simulate, for example, network jitter or network failures. Changing IAM roles is also interesting because imagine you have an application running on an EC2 instance that relies on the IAM role to access, for example, DynamoDB and S3. So if you remove the access to those backend AWS services to the instance, basically you're introducing a failure on your application that will be exactly if the application would have not access to those services. Also, one of my favorite ones is like injecting garbage in the etc host files. So you bypass the DNS resolution, and you can basically send requests that should go to a database to a black hole. And also Amazon RDS, if you're using for example RDS multi-AZ, allows you to test the failover of the master to the standby. So this is something that you can also use to test the application. And there's also the very famous Chaos Monkey. So Chaos Monkey, for those of you who don't know, is a software framework that has been designed by Netflix. So Netflix is a customer of Amazon Web Services, and because they run a video on demand application, a large-scale video on demand application on Amazon Web Services, they needed a way also to understand and to make sure that their architecture behaves properly. So the whole point of Chaos Monkey is to randomly delete instances, and now even EBS volumes, and see if the architecture is configured correctly. For example, if you have your auto-scaling groups replacing the instances automatically, so to really test if the architecture runs well. And apparently they also do that in production to the system. So if you don't want to do that in production systems yourself, fine, but test it during the game days. So you create a test environment, you inject incoming traffic to this test environment, and at the same time you run Chaos Monkey. So you're going to simulate failures and watch your team fixing those failures. Another point that you can test, and this is very important, because earlier I mentioned that game days is not only to train and test your team on how to respond on technical failures, but it's also to train them to behave in crisis situations, right? So you're going to see also how the communication channels are established within your team. So sometimes it's a disaster. There's very bad communication between the teams, and well, this is a good thing to know during a game day, not during a real crisis situation. And sometimes you have very good communication. But something that I saw in many teams is that sometimes you have a couple of key players in the team. You have a couple of engineers that know the system completely. They know all the logins, all the access credentials, and so on. They know how to fix everything. So when you do a game day, remove those players, because perhaps you want to do a game day where you simulate the fact that one of those guys is not available because he's on vacation, he has his wedding or whatever. So your team is constrained with the people it has, right? So also train the rookies during the game day, because for them it's also a good experience to see in which ways the system can fail, and try to find fixes by themselves, right? Also, as we mentioned, metrics are definitely key, because if you don't measure something, it doesn't happen because you don't see it, right? So once you have all the metrics, this is something that is going to be extremely helpful when you're going to do the debrief, because the game day obviously is a time boxed. You're going to do a game day perhaps for 8 hours, 9 hours, or sometimes I even saw a team doing it for 24 hours. And then during the debrief, this is when the supervisors are going to explain to the players what they actually did, and you are going to debrief the actions of the players. So why they took some actions, what are the decisions they took, which metrics they relied on to those actions, and so on. And for you, if you're running a game day, one of the most important things is, for example, to see how long a team is going to be able to detect an event, to detect a failure. Because keep in mind that if in a game day situation, when everyone is paying attention, it takes to your team, let's say, 4 minutes to detect that a read replica is down. In a real production environment, this is something that is going to take them half an hour because they will not be paying attention to this. So this is also the kind of things you're going to see during those tests. So at the end, the game days will allow you to validate your assumptions, to prove your architectures, and to really test if your team knows the recovery procedures. Because the more game days you are going to do, the more you are going to be able to write those booklets that will come with your internal documentation that will explain how to operate in certain conditions, how to recover a failed database, how to replace an EBS volume in a red 10 array, for example. So you will be able to fine-tune those procedures, but those procedures are only helpful if you know where they are and if you know how to apply them. Because again, keep in mind the main reason why we do all those tests, the load tests, the game days, is to really train the team in situations that are really difficult. And for that, AWS is the perfect platform, because again, as we discussed in the previous episodes and on this one, you have an environment that you are going to pay only for what you are using. So you're going to pay for this environment only during the game day. You can automate the creation of this environment just with a simple CloudFormation script. And you have also the control to simulate those failures through the console. So the perfect environment to run all the tests and the game days you want to train your team. So what we saw in this episode is that not only AWS gives me all the tools I need to create environments and deploy my software packages on them, but also use them in novel ways because of the model of Amazon Web Services. So we saw about the cost efficiency of doing game days, of doing load testing also on AWS. These are all good practices that will increase the quality of my application. And now with that, we are going to the Q&A section. Don't hesitate to ask us any kind of technical question. I'm here with Ian Massingham, and if we don't have time to answer all the questions, we're going to get back to you via email.